Hi, Spring fans. Welcome to another installment of Spring Tips. We're going to talk about something that's amazing, something that's near and dear, something that has just been top of mind for a lot of us of late, especially since late 2022 when ChatGPT burst onto the scene, AI. And it's potentially amazing and perhaps just a little bit scary implications. AI is a big nebulous thing, and it represents decades, literally decades, of research and investment and R&D. So we don't have the time nor the ambition to cover all of it. What we need to know today is how you can leverage it from your application. And that's, I think, what's very important here is in the same way that most people don't need to build their own SQL databases or their own message queues, most of us don't need to build our own LLMs. Instead, what we need is to be able to integrate those. And so today we're going to talk about the Spring AI framework. This is a fairly new framework. Indeed, it just graduated from experimental and is not even yet GA. So there's a whole pipeline here, and this is this idea of asking a question and in the body of that question, adding enough information so as to better educate the LLM about the context associated with the question. That whole process of refining the data and getting it into such a place where you can actually put it in the body, that is called retrieval augmented generation. The idea is I make a request of an LLM, the LLM has been trained on a certain body of data up until a certain point, and it doesn't know about anything since, right, that point. So if you want to teach it about up-to-date live information in your database, for example, you need to stuff the prompt. You need to add information, add any context required to then be able to act on that request. So today, my friends, we're going to talk about retrieval augmented generation with Spring AI and its various integrations along the way. So we'll look at the support for working with data. We're going to look at the support for storing things in a vector database. And then we're going to look at the support, of course, for talking to a large language model. There are different implementations and integrations for things like OpenAI, Azure, Hugging Face, Ollama, Bedrock, Vertex from Google, etc. So you can make your pick, but we're just going to look at OpenAI. And we're going to do that, as always, by starting a journey here at start.spring.io. We're going to use Maven. We're just going to call this AI. At the moment, the AI project is not on the Spring Initializer. Sadly, that's okay though. So we're going to go ahead and bring in the JDBC support. We're going to be using, there are a number of different vector store implementations out there. The one we're going to be using today is PG Vector Store, and that's one of the supported options for Spring AI users. And it's really convenient because all you need is a simple Postgres-based database with the right plugins configured. So we're going to use that. I'm just going to add the JDBC support, really. Do I need anything else? I guess I probably don't. Do I need Aspect? Maybe I want the AOP support. Right? Oh, I can add that manually. All right, let's just go ahead and hit generate and open this up. All right, so we have to go back to our build here. A couple things. We're going to use the Postgres support. I forgot to add that. So let me just copy and paste all these definitions from another project, and then we'll just go through them line by line just to make sure that we understand and are aware of every single dependency. Okay, very good. And we need a Spring AI version. At the moment, we're going to be using Spring AI 08 snapshot. Okay, now obviously this is subject to change. It's not even a GA release, but it's it's conceptually very interesting to understand the possibilities. Okay, so we've pasted the dependencies into the class path. Let's go ahead and see what we got. We have Spring Boot Starter JDBC. That's for the PG Vector Store support, and of course, it's always good to have a JDBC around. We've got the web support, not because we're necessarily trying to build a web service, but because we might use a web dependency. But I'm not even sure if that's required. We have the Spring AI, OpenAI Spring Boot Starter. We have the Spring AI PDF Document Reader and the Spring AI PG Vector Store Spring Boot Starter. So these dependencies allow us to work with the different pieces of machinery required to support our use case today. We're going to also bring in the AOP support and the retry support. One might argue that this should be part of the Spring AI dependencies, and perhaps it will work without it, but I'm going to cargo cult it and we'll just use it. You can try removing it and seeing if everything goes well. We have Postgres, of course, and then the test support, which is duplicated. Good. All right. AI application. Okay. So we've got our public static void main, and what we want to do, we know that we're going to be talking to data on the in a PDF. I want to be able to ask the LLM questions about data that it's going to discover in a PDF. So that data here is in the PDFs directory. Okay, I've got this file here called Medicaid Washington Facts. Okay, so this is about the Medicaid program in the state of Washington in the United States, and it's notice October 11th, 2023. So new, right? Newer than, at least as far as I know, all of the cutoff points for ChatGPT. So I'm going to be able to ingest this data, right? And then ask the LLM questions about it. I want to be able to teach the LLM about this so that I can then query it and provide kind of an IVR experience. We're going to initialize the pipeline to read the data in, and then we're going to ask our LLM a question about what it's just read with that data. So here's our initialization, our demo, right? Do that. Okay, very good. And we want to have a method that, first of all, resets the vector store implementation. So JDBC template. Okay, and we'll say template.update delete from vector store. Fantastic. Okay, and now I want to have a way to read data in. That data, by the by, will live in a PDF in the on my desktop. We saw that, right? So value, file, home, desktop, PDFs, and the PDF in particular is Medicaid, WAFAQS, PDF. Okay, so here's the resource. There's a template. I'm going to delete from the vector store. Let's connect, by the way, to that vector store. Okay, I have this Docker Compose file here that you can use to spin up your own vector store. I'll put that in the source code for this repository on github.com Spring Tips, and you can see it's uncain PG vector vo50, and I've got the usual environment variable specifying credentials, authentication credentials, health check, and even an admin if you want to be able to use that to administer the Postgres instance. I just tend to stick to the command line, so it's fine. Okay, so note, of course, that the database is vector_store. The user is Postgres. Everything else is Postgres. So, right, user, password, and so on is all Postgres. Okay, let's start that Docker Compose instance up. There we go. So now it's running in the background there. I can connect to it, right? PG password equals Postgres, PSQL U Postgres, H localhost Postgres is the database. Okay, and C vector store. Here we go. There's nothing in there at the moment. Okay, brand new vector store installation. So we want to delete from it if it exists, right? I want to be able to read some data in. Okay, so the goal here is to read some data, get it into a place where we can understand the text from the PDF, and then put that in the vector store, and then ask questions of our LLM pointing it to that vector store. Okay, so first things first, config. It is a bit of a mouthful, but basically we're just specifying how fast and loose we want to play with the text data in the PDF document. Okay, then we have the reader, which in turn takes the resource, which is that, and it takes the config that we just created. And now we have a text splitter, which will tokenize the data we just read. And now we can actually write that data to the vector store. And so in order to get that, we'll just inject a pointer to type vector store. And there are, again, a good many of these out there. You can actually, there's actually an in-memory one that comes with Spring AI that is, well, pretty easy to understand if you understand the math. I don't purport to understand it all. So it's looking at, it's able to, given text, kind of give you an idea as to whether it's closer or further away from some other text, right? And so we're going to use that to write data. We are not going to use the in-memory one, right? Even though it's just mathematically just very simple. We're going to use the Postgres-based one. We'll say vector store.accept, and then we'll put the documents in there. Text splitter.apply. PDF reader.get. Okay, so there you go. So there's our updated code. We're writing data to the PG vector store. So this configuration is going to configure our document reader for PDFs using the Apache PDF box API. Okay, so we then read it with this, split up the data, and then write it to the data store. Okay, very good. Now, let's just try running it. Remember though, we're dealing with PDF, so behind the scenes, things like missing fonts and whatever might vex you, right? You might actually be in a situation where you see errors about missing fonts. It's probably fine, but do be aware that might be an issue. Okay, so another issue, we need to configure our data source naturally. So remember what we just did. We just talked about Spring data source URL, JDBC, Postgres, localhost, vector_store. The username, the password, and the database are all Postgres. We have the database, host, username, password. Let's go back to our code, restart. See those errors? PDF, box, text. It's all about getting fonts on my Mac, fonts that are in the PDF that I can't load in my local machine. Not a big deal. Just be aware you might see some of them. You can always disable the log levels for those errors, right? If you wanted to, you could do, well, probably, I haven't tried this, but you could probably do something like this. Logging level blah equals debug, right? That usually works for most kinds of loggers. Okay, so it's still going. It's reading a lot of data. It's doing a lot of work. But there you go. It's finished its work, splitting up the document into 2 chunks. Has it finished writing the data? That's the real question here. And by the way, notice how this took a long time, right? This is not cheap. Okay, so there it is. We got a database now. So open that. Got something in there, right? So select count. Look at that, 13 rows. And we can ask questions like, what's in a given row, right? You got the content, the metadata, the embedding, and the ID, and that's a vector. Okay, very good. So we now have information about the PDF in our database, and we could rerun this every single time. I hardly see why, so let's just refactor into a separate method. Okay, I'm going to call this setup. There you go, and we'll just comment that out for now. Okay, so we have now a separate method here that we can use to reinitialize our database. I've commented out. Now comes the fun part. Actually talking to the singularity, talking to our API, okay? So let's go now and build a client, okay? And the client, in order for it to do its work, will use the Spring AI chat client. And here's where client, okay? Now, there are other clients out there, right? This is a model client. There you go, go back, you can see that. And that's good for text messages, right? That kind of things. But we also have support for image clients, right? So you can give it an image prompt and get an image response for all the different LLMs that support that. For example, ChatGPT 4 supports both text and DALL-E image-based generation. So depending on what you need, you inject the right implementation. There's going to be a lot more OpenAI. There's going to be a lot more textual chat clients than there are image-based clients, but there are a few of those as well, so it's just very convenient to have that as an option. Now we've got the chat client, and we can use. You can imagine building a CRM, or you can imagine building some sort of enterprisey app where there's an AI assistant, and you want to be able to have the AI respond with some knowledge about what you're doing and what the user is doing, and so we need to write the prompt, and this is actually a whole sort of type of discipline, right? Prompt engineering. How do you write your prompts in such a way as to give it enough information to be able to answer questions about whatever appropriately? So let's go ahead and do this. I love multi-line strings. They're not just for SQL anymore. Look at that. All right. Good stuff. Okay. So now here's our question. Here's our prompt. Okay. So there we go. So this is a pretty straightforward human language text, right? Prompt. And we're giving it a little bit of static invariant information that it needs to know for all responses. And then we're going to give it some information from documents, from the documents that we've just ingested, right? So let's just make sure our human text is pretty okay. Okay, looks okay. It's an AI. It'll figure it out. Okay, so now we've got the documents stanza. And now we can ask it questions. We've stuffed the prompt. So what we're going to do is send that prompt as a system message, which is sort of an overarching message that should be included in all other messages that get sent. Okay. So docs equals, list of similar docs equals this vector store dot similarity search, right? And then we're going to look for the message, and the message will be, okay, so we've got this prompt. I want to hide this complexity a little bit behind a chat client of sorts, right? So let's do that here. We'll say static class Karina AI client, right? Not bad. Okay, so string chat, string message. I'm going to put that prompt there. We'll say var list of similar docs equals this dot, and then we need the vector store, private final vector store. Okay. And put that as a bean. So this dot vector store dot similarity search message dot. I guess that's it actually. Got that. And then var docs equals list of similar docs dot stream dot map. Get the content, collectors joining. So we're just joining all the data from the similar docs into a thing. And then we can use that to create a bunch of documents that we're going to put in that prompt there. Okay, so we're going to create a new system prompt template. And the template will have the string that we just put in there, right? That's this thing right here, prompt. And we're going to create a message. And that message will have some parameters. Map.of documents, that's this parameter right here. And the value of that parameter is the collection of documents that we just created. Now we can create a user message, and this, one imagines, will be different for every user. User message, this is the parameter that we're actually asking, the question being asked by the client. And then we have a prompt list, right? So new prompt list dot of system message, and then user message. And then finally, we get the response for our AI implementation. Okay, so AI response equals AI client. And we want the chat client injected here. Do we have that? No, we don't. So private final chat client. Voila. Chat client dot call prompt list. Okay, and then we got the response. So we're going to say return AI response dot get result dot get output dot get content, right? Okay, so, and the reason that there's a get content and get output is because you can actually also get the you can actually also get those streaming results, the sort of line by line, but I prefer to wait for it all to get aggregated and then get the content, right? So content, voila. All right, so there we go. We're returning a string in response to this question using our Karina AI client, okay? Now let's inject that here in our little demo here. So I guess we don't need that. Well, let's just leave it in, it doesn't matter. But so we've got the Karina AI client. Now let's ask it a question. Okay, system out print line, Karina AI client dot chat, and let's look at the PDF, huh? Let's see, let's ask about this, okay, or something new. Here's something. This is a state change, right? What should I know about the transition to consumer direct care Washington? Okay, so let's put that here. Okay, that's our question to the AI, which is going to give us a string, which we're going to then print out using system.out.println. All right, let's run this whole thing again. And remember, we're not going to reinitialize the vector store. That should have already been done. So now we're going to talk to the thing. Oh, okay, the port is blocked. Let's restart the existing one. And now, of course, at this point, it's going to take a little while. It's actually making a network call to the LLM and doing the actual work of getting us a response. Here's a response, though. Cool, huh? CWA is responsible for providing employment, blah, blah, blah. Cool. So we got data from the AI, which is summarizing or synthesizing from what it's read in those PDFs, which we've given it in the RAG pipeline. It's summarizing and giving us a response based on our query. This is super convenient, and it was very quick, too. In just a matter of minutes, we went from having nothing to a retrieval augmented generation-based pipeline supporting OpenAI in this case, but there are a good many other options out there. We're also using PG Vector Store. And of course, this is just the beginning. I mean, you've only seen just the very simplest of examples here, but the idea here is that you can now have, with just a little bit of configuration, an easy integration with any number of different LLMs. I have been talking to OpenAI, obviously. Normally, you'd need to specify that, OpenAI API key. What I did was, before we started this program, I created an environment variable that looks like this, and I exported it in my shell and put an actual value in there and so on. You'll just have to trust me that I've done that, and you'll forgive me for not leaking my OpenAI credential. Remember, this is extremely IO-centric, right? But remember, Spring Boot 3.2 supports virtual threads in Java 21. That's why I chose Java 21. So I do this, and now, yeah, sure, it might be taking a few seconds to get a response from the AI, but who cares? You're not losing any thread capabilities. That thread, while it's parked waiting for that next byte to arrive from the AI, the virtual thread mechanism underneath in Java 21 and used all over the place in Spring Boot, once you set this property, will automatically park your waiting thread, business logic, somewhere and then relinquish the actual thread and let something else in the system use it until such time as that thread of execution is ready to continue because the bytes have come back or the thread.sleep has finished or whatever. So the cost of doing this now has gone down to basically nil. It's an amazing, amazing time to be a Java and Spring developer, my friends. All right, good luck. I can't wait to hear about what cool things you all start building